This woman is the reason why we can code. She was born in 1906, when women were not even allowed to vote in the United States. Yet she changed the world by writing the first ever computer program. First of all, she was a girl. Back then, girls were not encouraged to pursue engineering or mathematics. And secondly, she had asthma, which made it difficult for her to breathe and do physical activities. Because of her asthma, Grace couldn't join the other kids in playing sports outside. But after a few years, she left academia and joined the U.S. Navy during World War II. These calculations were very important because they needed to be accurate for the sailors to survive. This was one of the very first programmable computers ever built, and Grace immediately saw the potential of this machine. She realized that it could be used to do much more than just calculate artillery firing tables. It could be used to do anything that involved a lot of numbers, such as payroll or tax calculations. But they were also very tedious and error-prone, so the Navy was very interested in developing a machine that could perform these calculations quickly and accurately. This computer, called the UNIVAC I, was used for a variety of business purposes, such as payroll and data processing. It was also the first computer to be used for weather forecasting. At the Navy, Grace served as a rear admiral, and she helped develop some of the earliest computers. It led to the development of the first commercial electronic computer, and it also paved the way for women to enter the field of computer programming. So she spent most of her time at home reading books about science and engineering, faculty members about her experiences at the Navy. Many of them didn't believe her. This program, called the Air Traffic Control Expert System, or AC, was one of the first expert systems to be developed. ATEC was eventually acquired by IBM and used as the basis for one of their early artificial intelligence products. She also wrote articles about the issue. But her activism didn't stop there. She was one of the first people to develop practical applications for computers. She made programming easier and faster. She was a pioneer in the field of artificial intelligence. She was also an advocate for women in computer science. And there are also many young girls who are following in her footsteps and pursuing careers in science and engineering. She also helped to create organizations that would support women in computer science. If you did, please be sure to like the video. Thanks for watching. She showed people that it is possible to change the world through the power of computer programming. And she also showed people that it doesn't matter where you start in life. What matters is that you have the courage to follow your dreams. One of these organizations was the Association for Computing Machinery's Special Interest Group on Computer Science Education. The goal of this organization was to promote the study of computer science among women. Grace was also instrumental in the creation of the National Center for Women and Information Technology. This center provides scholarships and mentoring to women who are interested in pursuing careers in information technology. They thought that sexism wasn't a big deal and that it didn't exist at all. But Grace knew better. She had seen firsthand the kind of sexism that existed at the Navy, and she was determined to do something about it. This is Grace Hopper, and this is her incredible life story. She also developed a number of software programs that could run on the Harvard Mark I. She helped to pave the way for generations of women who would go on to make important contributions to the field of computer science. One of her most famous programs was called AO System. This was the first ever compiler. She was also a pioneer in the field of artificial intelligence. You see, Grace believed that computers could eventually be programmed to think like humans. She was one of the first people to work on developing expert systems, which are programs that can perform tasks that typically require human intelligence, such as diagnosing a medical condition. And it allowed programmers to write programs in a much higher level language that was closer to natural language. This made it much easier for humans to write programs for computers. At the age of 2, Grace was already interested in taking things apart. She did this by developing a new type of memory that could store multiple programs in one computer. This made it possible for computers to switch between tasks much more quickly. The Harvard Mark I was very expensive, and it was also very slow. It took several minutes for the computer to perform even the simplest calculations. So Grace set out to find a way to make computers more affordable and faster. When Grace was a little girl, she would take apart clocks and other machines just to see how they worked. And when she couldn't fix them, she would put them back together again. She liked fixing things. Her family didn't have enough money to buy her one, so she built one herself out of scrap metal. It didn't work perfectly well, but she was very proud of what she had accomplished. This motor was also the reason why Grace would eventually go to college. You see, she entered a science fair with her invention, but she was rejected because she was a girl. The judge told her that girls weren't allowed to participate in the competition, but Grace refused to accept this. She appealed the decision and argued that she should be allowed to compete against the boys because she had worked hard on her project. Her efforts paid off, and she became the first girl to ever win the first prize at that science fair. With this recognition, Grace went on to earn a scholarship to study at Stanford University. But Grace had two problems. When Grace turned 13, she decided that she wanted to build a motor. But Grace didn't study what she loved, engineering. Instead, she studied mathematics and physics. That's because she believed that if she openly pursued engineering, her classmates and teachers wouldn't take her seriously. So instead, she chose to study math. After graduating from Stanford, Grace got a job at Vassar College, where she became the first female full professor of mathematics. You see, before Grace joined the Navy, huge teams of people would spend weeks calculating artillery firing tables for ships, and that's when Grace met the Harvard Mark I computer. But there was a problem. She started by developing a new programming language. It was much easier to use than the languages that were available at the time. In addition to making programming easier, Grace also made computers faster. Grace's work on making computers easier to program and faster led to the development of the first commercial electronic computer in 1949. As you can see, Grace's work on making computers easier to program and faster had a profound impact on the world. But this doesn't mean that sexism disappeared. In fact, when Grace talked to other female students, Grace began to speak out against sexism in the field of computer science. She gave talks at universities and at conferences. Grace's activism had a profound impact on the world. But Grace's impact on the world didn't end there. In the 1980s, Grace began working on a project to create a computer program that could help air traffic controllers manage the flow of traffic. So as you can see, Grace Hopper's impact on the world of computer science is immeasurable. But perhaps Grace's greatest legacy is the inspiration that she has been to millions of people around the world. Although Grace died in 1992, her work continues to inspire people today. There are countless organizations and scholarships named after her. I hope you enjoyed this video about the life of Grace Hopper.